Hello friends, welcome to our channel STLT Electrical and Electronics Engineering. Today here I am going to discuss about circuit breakers. This is the part 1. Brief description of circuit breakers part 1. When a short circuit occurs in electrical supply line, large amount of current is flow. The amount of current may be 5 or 6 kiloampere to 25 or 30 kiloampere or more. The short circuit may be happened from 5 different ways. In between phase and earth, in between two phases and earth. These are called unsymmetrical fault. Fourth, among three phases, in between three phases and earth. These are called symmetrical fault. The first three faults are called unsymmetrical fault and next two faults are called symmetrical fault. In the case of first three faults, unsymmetrical fault, the currents in the three phases are not same. In the case of last two faults, symmetrical fault, the currents in the three phases are maximum and same. In the case of short circuit, the temperature of electrical apparatus like cable, conductor, transformer increases dangerously and damage and burn the insulation. During the short circuit period, electromagnetic forces generated between conductors, busbars may cause damages due to bending and displacement. Now the protective gears are arranged in such a manner that the faulty section is separated from the main network within a second. From unsymmetrical fault, the relay settings and operating times of relay are decided from symmetrical fault. From symmetrical fault, the circuit breaker ratings are selected. From unsymmetrical fault, the relay settings and operating times of relay are decided. And from symmetrical fault, the circuit breaker ratings are selected. Okay, next. Description of simple circuit breaker. In this system, two overcurrent relays and one earth fault relay are connected in such a manner that their one end of coils are shorted and the other end of two overcurrent coils connected with two numbers. This is two overcurrent relay coils connected with two numbers CTs of two outside feeders, and the middle portion feeder CT is connected with shorted common terminal of the two overcurrent relay coils and earth fault relay coil shown in figure 1. The other terminal of earth fault relay coil is grounded and other terminal of three CTs are shorted and grounded shown in figure 1. The two overcurrent relays of two phases will active when any balance overcurrent occurs in three phases. If any phase is earthed, then an unbalanced current will occur and that will flow through the earth fault relay coil, or any unbalanced situation is occurs due to open circuit and for any other reason the earth fault relay will active. When a relay coil is active, it closes the DC trip coil circuit, which energizes the trip coil, and the trip coil pulls the latch mechanism of breaker to open the breaker. Thus, the faulty section of the line is isolated from the main supply. There remains numbers of NO and NC contact in circuit breaker, which operates simultaneously with circuit breaker main contacts operation. The function of the NO and NC contact is maintaining of interlocking with associated isolator and giving input signal to semaphore indicators and other indicator lamp PLC SCADA system. The circuit breakers are also divided in two categories, mainly indoor and outdoor type. Okay, next. Here is simple circuit breaker configuration. Here is circuit breaker. Here is 3 CT, CT1, CT2, CT3 for 3 phases. Here is overcurrent relay coil, 2 overcurrent relay coil and earth fault relay coil. This is sorted, and the earth fault relay coil is grounded, and the CT is one side is shorted and grounded. Here is the trip coil, here is the battery bank, here is the trip coil circuit. This is figure 1. When this contact is closed by the overcurrent relay or earth fault relay, the trip circuit is closed and the trip coil is energized, and this pull the latch mechanism and the circuit breaker is opened. Okay, next. Theory of AC circuit interruption. There are fixed and moving contacts in every circuit breaker during the flow of load current. Fixed and moving contacts are closed together. The opening of breaker is done either manually or automatic. During opening of breaker contacts, arc is created in between the contacts. When fault current flows during opening of breaker contacts, the arc occurs in between contacts heavily. This arc is actually ionized gas column. During opening of breaker contacts, there exists potential differences between contacts, especially for HT and EHT breakers. The arc maintained until it is stopped. The ionized gas or air column act as a low resistance conductor. Once arc is occurred, it is maintained at low voltage. The voltage is called arc voltage, shown in figure 2. In the case of alternating current, the current value is 0 twice for every cycle or in 1/50 second. In the moment of zero current, the arc voltage quickly reaches to its maximum value temporarily and maintain temporarily over voltage in between the contacts. Again, this voltage rapidly increase and decrease in respect of natural voltage curve until it comes to natural alternating voltage. The increase and decrease voltage is called restriking voltage transient or RVT. The voltage is responsible for generating of arc. At the voltage when the arc is disappeared completely and the natural voltage is established is called recovery voltage. The establishment of arc depends upon the restriking voltage. Again, the value depends upon the power factor of the line. Low power factor causes high distriking voltage. Here in figure 2 it is shown 0 power factor lagging, fault current lagging 90 degree behind the voltage. To extinguish the arc between the contact completely, the rate of rise of dielectric strength should be greater than the rate of rising striking voltage between the contacts. Okay, next. This is figure 2. Here is the circuit EMF. This is circuit EMF. This is the arc voltage. This is the restriking voltage. And this is the recovery voltage. And this is the short circuit current. Okay, next. There exist different types of circuit breakers, some of them briefly discussed here. 1. Air circuit breaker, 2nd vacuum circuit breaker, 3rd bulk coil circuit breaker, 4th minimum oil circuit breaker, 5th air blast circuit breaker, 6th SF6 circuit breaker, it is 7 miniature circuit breaker, and 8 molded case circuit breaker. Seven miniature circuit breaker, 8 molded case circuit breaker, air circuit breaker. In this type of breaker, the fixed and moving contacts are remain in air. The closing and opening operation of contacts are done in air media. In this breaker, two main copper contacts, one for incoming and other for outgoing, are fixed in switchboard, and one main moving contact made of copper are used. Two number spring loaded arcing contact fixed on the main fixed and moving contact in such a manner that the arcing contacts make before and break after the main contacts. Thus the arcing is occurred only in between arcing contacts only. When arc is generated during closing and opening operation, the arc is separated towards upwards arc chute due electromagnetic force and temperature rise. There are splitter plates made of insulating material in the arc chute, where the arc is splitted finally extinguishes, shown in figure 3. These type of breakers are used up to medium voltage range 415 volt. There are three types of air circuit breaker: EDO type, electrically operated draw-out type; MDO type, manually operated draw-out type; EF, electrically operated fixed type. The basic difference in EDO and MDO lies in the way the spring is charged. In EDO type breaker, spring is charged by electrically operated motor or manually. In MDO type breaker, spring is charged by only manually. Okay, next. It is figure 3. Air circuit breaker view are shown. Here it is arc chute. Here it is splitter plates. Arcing contacts 1 and 2. This is spring. This is main contacts fixed, and this is main contacts moving type. This is flexible conductor across hinge. And this is a figure of air circuit breaker. Okay, next. This is bulk oil circuit breaker. In bulk oil circuit breaker, there is a steel tank where the fixed and moving contacts are immersed in insulating oil. There is lining of insulating material on the surface inside the tank. 6 bushings are fitted on the top cover of the tank, to which fixed contacts are fitted, shown in figure 4. The moving contacts are lying under the fixed contacts. These contacts are stayed on a insulating rod. This rod is connected with link mechanism outside the tank. When the breaker is closed, then the fixed contacts are connected with the moving contacts with the help of latch mechanism. When a fault is occurred in the line, relay is activated. Then the tripping coil also energized and pull and remove the latch to make the moving contact separated from fixed contact due to weight and spring pressure. During separation, heavily arc is created, and this arc is extinguished in oil medium, shown in figure 4. For low voltage and low power, all the 3 phases remain in the same tank, and the insulating barrier is given between 2 phases to separate the 2 phases. For high voltage and high power, 3 phases remain in 3 separate tanks. To reduce gas pressure upon oil inside the tank, a vent pipe is used on the upper portion of the tank. For control the arc in high voltage breaker, cross jet explosion pot is used. Here, fixed and moving contacts of each phase remain inside a insulating shell. Moving contact can slide through the bottom of the shell. There remains some vent in one side of shell. During breaking of contacts, high gas pressure produced for the reason of arc generation. Due to this high gas pressure, the gas and the arc pass away through the vent outside the shell. Again, due to high gas pressure, the moving and fixed contacts separate fast. In some case, there is some magnet inside the cell. In some case, there use some magnet inside the cell to pull the arc toward the vent. This type of breaker uses for up to 33 kV line. Okay, next. Here it is figure 4. The picture of bulk coil circuit breaker. Here is the bushing, here is the conductor, here is the spring, dielectric coil, moving contact, tank, and this is the arc. This is the fixed contact. This is the fixed contact, the moving contact. This is spring, bushing, conductor. This is a picture of bulk coil circuit breaker. Okay, next. This is minimum oil circuit breaker or MOCB. Minimum oil circuit breaker MOCB is called a small or poor oil circuit breaker. It required a small percentage of oil, about 10% of oil used in the case of bulk oil circuit breaker. The oil is mainly used for the arc extinction process only, but in the case of bulk oil circuit breakers, the oil serves two purposes, i.e. as a quenching medium, arc quenching medium, and also used as an insulating medium. In the minimum oil circuit breaker, the current interruption takes place inside the interrupter. The enclosure of the interrupter is made of insulating material like porcelain. So, the clearance between the lip parts and the enclosure can be reduced, and lesser quantity of oil required for internal insulation. One pole of a 3-pole outdoor minimum oil circuit breaker is shown in figure 5. There are two chambers are separated from each other but both filled with oil. The upper chamber is arc extinction chamber. The lower chamber is called supporting chamber. The oil from upper chamber does not mix with that the lower chamber. Arc extinction device is fitted to the upper fixed contact. The lower fixed contact is ring shaped, which consists of moving contact such that it can slide through the ring shaped lower contact. There exists a continuous electrical contact between moving contact and lower fixed contacts. A resin bonded glass fiber cylinder encloses the contact assembly. This cylinder is filled with oil. The porcelain cylinder encloses the fiberglass cylinder. The operating rod is operated by operating mechanism. The 3 poles operate simultaneously. Under abnormal condition, when there is a fault, the moving contact is pulled down by the operating mechanism. When the moving contacts start separating, an arc is drawn between the two contacts. As the contacts are immersed in the oil, the arc energy increases the temperature of the oil. The oil surrounding the arc attains high temperature and gets vaporized. Thus, gas will produced and will expand inside the chamber so that the pressure inside the chamber increases. The produced gas move upwards by decreasing the arc energy, splitting the arc and cooling the contacts by movement of oil. This procedure runs repeatedly until the arc extinguishes. Okay, next. Here it is figure 5. The picture of minimum oil circuit breaker or MOCB used up to 132 kV. This MOCB used up to 132 kV. Here is the gas vent, here is the oil level, top chamber, breather, terminal 1, upper fixed contact, gas fiber enclosure, moving contact, lower fixed contact. Here it is terminal 2, circuit breaker chamber made of porcelain, arc control device. This is breather. This is top chamber, porcelain insulator, supporting chamber, operating rod. Here it is drain valve. This is the picture of minimum oil circuit breaker MOCB, and this is used up to 132 kV voltage line. Okay, next. Here it is the picture of 3-phase outdoor MOCB. First one, oil level indicator. Second, circuit breaker chamber. Third, supporting chamber. Fifth, structure. Sixth, mechanism box. 4 is 3-pole interconnection housing. This is 4. Here it is the picture. The figure 6 is the picture of 3-phase outdoor type MOCB. Okay, next. Now here it is vacuum circuit breaker. Vacuum is a perfect dielectric medium. The conductance of vacuum is 0. In vacuum circuit breaker, arcing occurs in airless region. Due to absence of air, the arc is extinguished when the current becomes 0. The main parts of the circuit breaker is a vacuum interrupter. It is a vacuum chamber made of glass, ceramic or fiberglass where the fixed and moving contacts remain. The interrupter includes a steel arc chamber within the center of symmetrically placed ceramic insulator. The vacuum pressure inside the interrupter is maintained 10 to 8 mm of Hg. The vacuum circuit breaker performance mainly depends on the material used for current carrying contacts like copper or chromium. Once the circuit breaker contacts are opened due to fault within the vacuum, the total current is divided into several parallel arcs between the gap of two contacts through the metal vapor ionization in the contacts. The arcs generated in this process repel each other and spread over the contact surface, but the arc can be quenched easily as the electrons, ions, metallic vapors are generated throughout the arc quickly condense over outside the circuit breaker contacts, CB contacts. So, the dielectric strength can be quickly recovered. The most important feature of a vacuum is that once the arc is generated within the vacuum, then it can be extinguished quickly because of quick improvement rate in the dielectric strength of the vacuum. From figure 7, the moving contacts move through a stainless steel bellows. The stainless steel bellows enable the permanent sealing of the vacuum chamber so as to avoid the likelihood of leakages. Ceramic envelope is used as the outer insulating body. The spring mechanism is connected to the lower bottom of the breaker to move the metallic bellows. This type of breaker is used from 11 kV to 33 kV line. Okay, next. Figure 7. Here is the sectional view of vacuum circuit breaker interrupter. Here is fixed contact, moving contact, arcing chamber, ceramic insulator, fixed contact stem, fixed terminal pad. Here is the bellows, guide, moving contact stem, mechanical coupling for operating mechanism. Here is the arc shown, fixed contact, moving contact, and this is the sectional view of vacuum circuit breaker interrupter. Okay, next. Here it is air blast circuit breaker. Air blast circuit breaker is mainly used in outdoor. In this type of breaker is opened or closed by high pressure air. During opening of breaker, plenty of air driven through the arc. As a result, the arc length is increased and the arc is quenched, shown in figure 8. In figure 8 shown that there are two fixed contacts remain between porcelain pushing. The moving contact sliding through it, shown in figure 8. The two terminals are taken from the two fixed contacts. There are three air tubes remain with bushings. The lower air tube is for air intake to close the breaker by push of the moving contact. The middle portion of the air tube is for open the breaker and the air is intake during breaker opening and remove the arc by third and uppermost air tube. In practice, the two fixed contact and one moving contacts remain in porcelain shell, which is called interrupter. the air is supplied from a compressed air tank. When the tripping is occurred, the tripping valve of air chamber is opened and the air is entered the interrupter to open the contacts. According to voltages, two or more interrupters are connected in series. This type of breakers are mostly used in 132 kV and above line. During opening of fixed and moving contacts, arc is generated in between the contacts. There remains auxiliary contacts parallel with the main contacts shown in figure 9. The auxiliary contact connected in series with large value carbon ceramic resistance. During the tripping of breaker, the resistance is connected first with circuit by compressed air. After extinguish of arc, they are separated from the circuit. During opening of main contacts and auxiliary contacts, arc is created. A part of arc is divided through the resistance. Due to flow of air, the arc is reduced. With reducing of arc in main contact, increasing of current in auxiliary contact started through the resistance. At last, all the current started to flow through the resistance. As a result, the arc is quenched due to existence of large amount of resistance in series. Striking voltage increases very small amount and the arc of auxiliary contact quenched quickly. Okay, next. This is figure 8, main theory of air blast circuit breaker. There is a way of entry of air during closing. Way of entry of air during closing. This is the plunger. This is fixed contact, moving contact. This is moving contact. The way of entry of air during opening. Way of entry of air during opening. This is the plunger. The moving contact, fixed contact. Way of entry of air during closing. Main theory of air blast circuit breaker is figure 8. Okay, next. This is a picture of air blast circuit breaker used for high voltage line. Here it is auxiliary contact with resistance and this is the main contact. Porcelain housing of resistance 1. Second, porcelain housing of auxiliary contact 2. Third, chamber. Fourth, compression spring. This is the compression spring. Fourth. 5 is piston. 6th, resistance. Here is the resistance. 6th, resistance. 7, moving contact of main. 8, hollow insulator. 9, fixed contact main. This is moving contact and this is fixed contact. 10, auxiliary contact. This is auxiliary contact. Here is the resistance which control the striking voltage to a lower value. For this reason, the arcing in the auxiliary contact is quickly quenched. Okay, next. Here it is SF6 circuit breaker. SF6 Sulfur hexafluoride is an inert gas. It does not react with metal, glass or porcelain. The gas can easily remain in this type of pots. The dielectric strength of SF6 20 kV per 2.5 mm is twice the value of air at natural air pressure 76 mm of Hg. The dielectric strength increases with the increase in SF6 gas pressure. There happens no explosion and the arc quenching capacity also better for SF6 gas. The fixed and moving contacts remain inside the interrupter filled with SF6 gas at 5 kg per square centimeter. Puffer principle. Refer figure 10A and 10B. As the puffer cylinder moves downwards for opening the breaker, the pressure ratio P1 by P2 rises as shown in figure 10B. The pressure rise depends upon the throat diameter of nozzle and speed of puffer cylinder. The pressure ratio P1 P2 increases to about 5 times during opening condition. The compressed SF6 gas is released through the convergent divergent nozzle. The arc is quenched at a current 0. At higher voltage rating and higher short circuit current rating, SF6 is supplied to interrupter from outside compressed SF6 tank. At the time of arcing, SF6 is broken to SF4, SF2, S2, F2 inside the interrupter. At the time of cooling, again all the components are converted to SF6. Due to explosion free and very quick arc quenching time, this type of breakers are used from 33 kV to 400 kV installation. When it is used for indoor, then 3 breakers for 3 phases are placed inside metal clad and placed upon track. In the case of outdoor 3 phases are placed separately inside the porcelain cell. For 220 kV and 400 kV system, 2 or more interrupters connected in series. The operating mechanism may be pneumatic, spring control, hydraulic control. Okay, next. Here it is figure 10A and this is figure 10B. The cross-sectional view of SF6 interrupter. The first one is fixed contact, second fixed arcing contact, this is fixed arcing contact, third insulating nozzle, this is insulating nozzle, fourth moving contact, fifth moving arcing contact, fifth moving arcing contact, sixth porcelain. And here is shown at the time of opening of the SF6 breaker. This is come down and the moving contact come down. This is shown by the arrow, and the SF6 gas goes through the path, and the arc is quenched by the gas. This type of mechanism called puffer mechanism. Okay, next. Here is general description of MCB and MCCB. MCB means miniature circuit breaker. Miniature circuit breaker is a safety accessory and switch that opens when the excessive current, overload and short circuit flows through the low and medium voltage 240 by 415 voltage circuit. These are activated generally at 125% of rated current. The short circuit current rating is generally 10 kA. 4-pole MCB is shown in figure. These are of single pole and neutral SPN, double pole or DP, triple pole or TP, triple pole and neutral TPN, and 4-pole FP. According to the rating of pickup value of current, this will be of B type 3 to 5 times. This is used for lighting circuit, heater, geyser, etc. B type 3 to 5 times. C type 5 to 10 times. This is used for where sodium vapor lamp, motor, air conditioner, machine tools. C type 5 to 10 times. D type 10 to 15 times, where more overload current, pickup current is are required. That D type 10 to 15 times MCB used. The MCB current ratings are 0.5 ampere, 1 ampere, 1.6 ampere, 2 ampere, 3 ampere, 4 ampere, 6 ampere, 10 ampere, 16 ampere, 20 ampere, 25 ampere, 32 ampere, 40 ampere, 50 ampere, 63 ampere, 80 ampere, 100 ampere, 125 ampere. Here is a picture of 4-pole MCB. Molded case circuit breaker, MCCB. Molded case circuit breaker. These types of breakers mainly used for medium voltage 415 voltage motor and feeder circuit protection. It is another type of electrical protection device for medium 415 voltage installation, which is used when load current exceeds the limit of a miniature circuit breaker. The MCCB provides protection against overload, short circuit faults, and is also used for switching the supply. It takes comparatively less space than equivalent rating switch fuse unit and air circuit breaker. There are two types of release associated with MCCB: thermal and magnetic and microprocessor release. The three-phase MCCB, mainly of 3-pole or 4-pole, here in figure 3-pole MCCB is shown. 3-pole MCCB is shown. The general ratings of MCCB are of 25 ampere, 40 ampere, 63 ampere, 80 ampere, 100 ampere, 125 ampere, 160 ampere, 200 ampere, 250 ampere, 320 ampere, 400 ampere, 630 ampere, 800 ampere, 1250 ampere, 1600 ampere. Short circuit ratings: 25 kiloampere, from 20 ampere to 630 ampere, and this is 36 kiloampere short circuit ratings from 20 ampere to 630 ampere. 50 kiloampere from 100 ampere to 1600 ampere, and 70 kiloampere from 100 ampere to 1600 ampere. Okay, thank you for watching the video. If you think the video is useful to you, then please subscribe our channel and share it to your friends. In the next video is the circuit breaker part 2. I shall discuss more about circuit breaker. This is a very vast chapter. I try to discuss to my friends briefly. Okay, thank you for watching the video. Bye.